Hi IoT builders and welcome to another video. My name is Nenad and I'm a senior developer advocate for IoT at AWS. And today I'm going to talk about fleet provisioning for embedded Linux devices with AWS IoT Greengrass. So there is a general challenge to streamline the process of onboarding a fleet of devices that can be later used by high-level application developers that use AWS IoT Greengrass, while also ensuring the security best practices are followed. So in this video, I will guide you through setting up the AWS cloud infrastructure to allow fleet provisioning by claim, and then building a Raspberry Pi Yocto image with Greengrass and fleet provisioning plugin using Meta AWS layer. So this solution will allow embedded system engineers to embed those claim certificates in the Yocto image, where this image can be distributed to a fleet of devices at the factory line, for example, enabling these devices to self-provision once they are turned on and connected to the internet. So for those who would like to follow along, there is a blog post that goes over this topic, and it will be in the description of the video. Okay, so let's start with the provisioning by claim and how does it work. In general, for devices to establish a secure MTLS, mutual TLS connection with the AWS IoT, they will require a unique client certificate that proves their identity. However, distributing those client certificates to a fleet of devices can be challenging. So for that reason, fleet provisioning by claim might be a better option. In that scenario, just a claim certificate can be embedded in the device that can later request a unique certificate upon initial boot over a TLS connection. So this is done by device publishing a request to a predefined topic. In this scenario, it's AWS /certificate/create/JSON, where AWS IoT Core creates the certificate and the key pair and informs device on the AWS certificates create JSON accepted on a successful creation. At that point, the device needs to inform the AWS IoT Core about the provisioning template, which one can be used. And this is done by publishing on AWS IoT provisioning templates and then the template name, provision JSON. At this stage, the device can send more information in form of parameters to be used by the template. This information can be serial number, thing name, thing group, and so on. And once all of this is received by the AWS IoT Core and interpreted based on the already provided template, the provisioning of the device can start. But of course, if additional checks are needed to be performed, there could be a trigger for a pre-provision Lambda function that can perform validation logic, such as checking the device serial against the table of verified devices, and make this kind of a bit more additional security on top. So, and after the completion, as I mentioned, the template will be executed, and the necessary provisioning will happen. And then the device will be instructed kind of to start using the newly created certificate, which is unique to that specific device. And this is done, informing back the device is done through this $AWS/provisioning template / the template name that's used / provision / JSON / accepted topic. So luckily, Greengrass already has a plugin that does this type of provisioning, and it's integrated in the Meta AWS, so we can use it to build a single image that embeds it and goes over the process to perform this self-provisioning. But before we jump into building the image part, we need to prepare the necessary roles and policies and add the provisioning template to be used in this scenario. So I'll now switch to my workspace, but as a prerequisite, it's important to have the AWS CLI installed and configured. And also, please note that here I'm using the Cloud9 to build the Yocto image and set things up, but you can use any editor and terminal you prefer. Okay, so let's start with the cloud provisioning template. So here we have a bunch of parameters that we can change. I will be using just default ones. The parameters are for the names of specific templates, specific roles and policies. And we will start with first creating the GG token exchange role. This role is used to access other AWS IoT or AWS services from the device. We'll be creating a role alias that will be used later, and then the provisioning role. So the provisioning role is more or less building on top of the policy that is standard AWS IoT things registration one. So we will be reusing that one. And then we will create the default policy. This will be the policy that's going to be attached to our newly created certificate for that specific device. So that specific device will have access to specific resources. So this is like connect, subscribe, receive, and Greengrass as well, since we are provisioning a Greengrass device. And then provisioning template. So for this provisioning template, we will be using parameters that come from the device. This is specified in the configuration file, which we will look later. But they will be coming from the device, and the device will be sending its own thing name, thing group, and the certificate ID. So the general thing here is like how we are informing this AWS IoT core through this provisioning template on how to create those resources. And here for the thing, we will be using the specific thing group. That is the thing group that's basically provided via the parameters, and the thing name, that the name of the thing that's going to be provisioned, that's also provided by the device. And then finally, we are giving it the device, the policy that we just created here to be attached more or less to a certificate, and of course the certificate itself. So this is the template. It's really basic. It's a really simple one. Of course, you can feel free to extend it. I will post the link in the description of more information how those provisioning templates are built and extended. And then finally, we will use the GD provisioning claim policy. This will be the policy that will go on top of the claim certificate. And there is a certain restriction here, so that claim certificate can only connect, publish, and receive, and it can only do this on the specific topics that we just mentioned, which it will allow it to go through that provisioning process. And as an output, we will have more or less all of those listed out, so we can verify and reuse them afterwards if needed. Okay, now so I can go and copy and paste this command that will create the resources defined in the cloud formation template. So let's execute this. Okay, I can see that this is the stack ID that's been created, and then more or less, let me just grab this to see the status. Usually it will take a couple of minutes. Okay, so let's check if the resources are created. So we can do this by describe the stack. So yes, we see here that the resources are there, and the status is complete. So now we can actually proceed with creating the claim certificates. So those are the certificates that we will need afterwards to embed into our image. I will just first create the claim directory and more or less copy this command here, which will execute the AWS IoT create keys and certificates, put them in that directory, and set them as active, and then query the certificate IRN, which we'll need later. So, okay, this is done, and then more or less we can check the. So yes, we have this. This is important. We will use it later. And I will also get a root certificate, the CA, so that we have it as well, because as I mentioned, we'll need to embed this. Okay, and now we just need to attach the policy to a certificate. So this is the policy that we created via the CloudFormation. And then let's attach it to the newly created certificate IRN. And finally, let's create a team group in which the devices will be provisioned in. So in this scenario, I'll be creating the embedded Linux fleet. Okay, so this is done. We are ready now with the steps to prepare the cloud in order for us to start building our image for those devices once they are flashed and connected to the internet to start onboarding. So let's start with building the RPI image. For this, I would actually like to export a couple of variables. Again, this is all from the blog post. So the variables are the base year, which is the current one. Then the distribution is Pocky, Raspberry Pi 4, and I will be working with Kirkstone as the version of the Yocto. So let's, I'm just copying pasting this commands here. So now I'm cloning the Pocky, which is a part of the Yocto project, and then I will need to clone also the Meta Open Embedded, the Meta Raspberry Pi, Meta Virtualization, and the Meta AWS. So all of those will be needed for us to have that set up. So, okay, so let me paste this here. So now we're calling the Open Embedded. Please note that here I'm using the branch as the argument and the destination as well. So I finally Meta AWS, and you should see this things popping here to the directories. Okay, so now that that's done, we can just go and more or less source the build environment. So yeah, now we will be able to build the image. But before we do that, we need to make sure we add the appropriate layers. So let me just copy the layers needed. So this is the Meta OE, the Open Embedded, the Python, the file system, networking, virtualization, the Raspberry Pi, and the Meta AWS as well. So those are the layers that we need to have in our builds. So we should see them here. So they are correctly added. And then finally, we need to make sure to have our configuration appropriately set. So I'm just going to copy paste this from the blog post since we are going to build this for the Raspberry Pi. So that would be the first part, which is just a standard configuration, which is not that interesting for us. But the second part is the important part, which we will be adding, and that is the thing that we will be to our image appending a Greengrass bean, which is a recipe we will be using for building the Greengrass and then embedding it. And then we will have a couple of more parameters to add here. I will get back to them. The thing name will be the embedded Linux thing. The GGB2TS role alias is the one that we created using the CloudFormation, and the theme group that we also created. And then this would be the standard settings that you will have when building Greengrass, but we will now use the fleet provisioning feature. So for this, we will just add that as a flag in order to enable it and then build it. for this, what I mentioned with the region, so you can just type in the region here, and then, for example, for the GGV2 data endpoint, you will see that there is a command in the blog post, but it will looks like something like this. So you can use AWS output text IoT describe endpoint, and this will give you the endpoint, which you can then just copy and replace. And then for the credentials endpoint, you can do something like this, which will then give you that credentials endpoint. So I'll not do this, so since I don't want people publishing to my endpoints. And then finally, the important part to note here is that in the recipe IoT Greengrass, there will be some files to kind of make sure that we can append to if we are creating the BB append and so forth. One file that is important, which kind of gives this uniqueness and appends it to a thing name, is the replace port ID. So here in this example, we're just taking the default interface and getting the MAC address and then replacing this in our config. So this is how the config for the fleet provisioning look like. So this will all be populated, and then the thing name will be it will be added, the uniqueness will be added to the thing name here. So that is important to note. If you want, you can create a BB append and kind of override those files, which is, needed. And then after that, we need to make sure to copy the claim certificates. Again, you can do this via the BB append as well. Okay, and I will just copy the claim certificates. So let me take this here. So that will copy the claim certificates to this location I mentioned here. So let's do this here so we can see them here, and they will be then embedded in the image. So I think this is all we need. Let me just go back to the build directory. So copy and then build. So we have all this set up here, and then we can execute the bitbake core image minimal. So this will start the process, and it's usually, depending on the size of the machine, takes around 40 minutes or so. So I'll come back after that is done. And finally, we have the image built, and now we will download this. So I will download this to my computer. This is running in a Cloud9 environment. So the image will be located into this TMP glibc, and under deploy images Raspberry Pi, and then I will have this core image minimal Raspberry Pi, and then RPi SD card image. So I will download this. So yeah, this will take some time to download. I think this specific image is 620 megabytes. So I'll come back once that is done. Okay, so now this is downloaded. Let's check which Greengrass devices we already have. We should not have any. So let's see. Yeah. So as we see here, we don't have any Greengrass devices onboarded as of now. And now I have this downloaded. So let's move to the console so that I can flash this to the SD card image. And then I'll plug it into the Raspberry Pi and see if we get some of the devices onboarded. Okay, so now let's execute the command. So first of all, we want to list the available disks, and this is my SD card reader. So I will be flashing this one. So please double check, otherwise you might be crashing your system. So please pay attention to this. And then secondly, I will unmount this And you can see I already had the the device flashed before, and then I'll just execute this command. So this is where I downloaded my core image minimal that we built, and we'll just flash it using this dd command. Let's start this. This will ask you for the password since it's a sudo, and then the process will take some time. So okay, so this is done now. So what I will do is I'll just unmount, and then I will pull up the SD card, put it in my Raspberry Pi, which is then connected via Ethernet, and I'll power it, and then we'll come back to see what changes. Okay, so I unplugged the power, put the SD card in, plug the power cable back to the Raspberry Pi, and put it on the Ethernet cable. And let's go back to our other terminal and list to see if there are new devices onboarded. Okay, great. So we can see our device now onboarded, which is the L thing as we specified there for the thing name, and this is the MAC address appended to the name. So we now get a new device. So if I repeat this process and have other devices as well, we will be kind of seeing this with the same image for each device kind of being onboarded with that uniqueness as we mentioned, the MAC address. Excellent. This is exactly what we wanted. So with that, we conclude this demonstration. When it comes to reaching out, so feel free to, put your comments if you have some questions in the video below, or just reach out to us via LinkedIn or Twitter, whatever you prefer. Thank you once again. We will have a follow-up on this now once we have the Greengrass deployed. How can we start deploying those applications on top of it? So stay tuned.